graders, we are continuing our journey with subtracting integers, but today we're going to be looking at building a model with a number line. So when we are looking at how to subtract integers on a number line, we are going to be continuing our journey of finding out why subtraction is like addition. Today, you're also going to be looking at absolute value. Because we are using a number line, we're going to be seeing the distance from 0 that we're going to be going back and forth in order to solve some of these problems. So the first problem that we have today is a positive 3 minus a positive 4. And so because we're doing this on a number line, we're going to first build our number line here. So I have 0, 1, 2, 3, 4, 1, 2, 3, 4. Three, 2, 1. Okay, so we are going to be looking at how do we go from a positive 3 to then subtracting a positive 4 when we don't even have positive 4 to subtract. So we're going to look and see how that works. So the first thing that we want to do is we want to look at the first number, just like we did last week when we were adding. So we're going to start here, and we're going to look at the positive 3. So I'm going to start at 0, and I'm going to go 3 places this direction and stop. So I have a positive 3. Now it wants me to take away positive 4. Well, I don't have positive 4 to take away, and so subtraction means getting smaller, and so I'm going to take away everything I can take away, which is this 3, and that puts me back at 0, and now I have to cross over 0 and go to negative 1. So I've ended at negative 1. So that means that I had to take away something that wasn't even there to begin with. I'm smaller than 0. So if we were to do this with our chips, when we're looking at our chips, we start with 3 chips, and we need to take away a positive 4 chips. Well, I can't take away positive 4 chips because I don't have positive 4 chips. So I have to create that possibility of taking away 4 chips by adding a 0 pair. Once I've added this 0 pair, I now have 1, 2, 3, 4 positive chips I can take away, and that leaves me with a negative 1. Same thing here, negative 1. So how is this just like adding the opposite? Well, it's the same thing as saying I have 3 plus a negative 4. So I had 3, and now I'm going to add negative 4 onto it, and I have negative 1. That's the difference between all of this. Because those are the 0 pairs right there, so they just cancel out. All right, I'm going to draw it in chips over here so you can see the chips, because I feel like we need to see chips. Okay, so there's the 3, and I'm going to add on a negative 4. My 4s cancel out. My 0 pairs cancel out. And I'm left with a negative 1. Negative 1. Okay, let's do another example. As we're working through this, I know that sometimes it can be a little bit confusing. So let's go ahead and think about what this looks like. All right, we're going to do negative 2. Negative 2 minus Okay, so I'm starting with a negative. So that means I'm already going to be below 0. And then I need to subtract a positive 4. So let's go ahead and build our number line here. Okay. All right, so I am at negative 2. Okay, so I'm going to start at negative 2, start at 0, and then I need to go to negative 2, which is right there. So I've started at 0, and I'm I'm going to negative 2. Now, it wants me to subtract 4 more. So I need to subtract 4 more. So if I'm subtracting means getting smaller or removing things. So I need to remove 4 more in order for this to work. So from negative 2, I am going to continue on my negative journey and remove 4 more, which puts me at negative 6. So I've jumped 1, 2, 3, 4, 5, 6 places from 0 when I've solved this problem. Now, this one, the answer is negative 6. Let's look at this as a chip problem. Okay, so I have my negative 2, and they want me to subtract 4 positives. Well, I don't have 4 positives to subtract. So I need to create the possibility of subtracting 4 positives. So I'm going to add on 0 pairs until I have 4 positives that I can subtract. Okay, I now have 4 positives to subtract. So those are going to go away, and I'm left with 6 negatives. 6 negatives. Now, if I rephrase this as addition, so let's draw this out as integers. I had negative 2, and they want me to subtract 4 positives. So to subtract 4 positives, I have to create the possibility of even having 4 positives. So I'm going to add 0 pairs because that's no value. So there's no value here until now I take away 4 positives. So now that my 4 positives are gone, there they go. I now have 6 negatives. So number line, chips. The number line, it's harder to see that you've created the possibility of taking away 4 positives. We didn't have 4 positives to take away. This number line is exactly how, when we did negative 2 plus a negative 4, that's what this is showing. You had negative 2, you had negative 2, right? And then you took away, or you added 4 more negatives to it. I'm adding 4 more negatives to my negative 2. 1, 2, and now I need to jump 4 more times. 1, 2, 3, 4 more jumps. This gives me negative 6. So creating this possibility shows that you're not able to subtract anything if it's not there. Here, you're adding on negative 4 more. This problem does not show what the math is that's actually happening. So we rephrase it as addition. Okay, let's do another problem. This problem is really weird because you're going to see the negatives and the negatives, okay? So we have -3 minus a -7. All right, so I have, oops, my number line. Let's go ahead and set up our number line here. Okay, so the first thing is that it says for me to go to -3. So I need to start at 0 and jump to -3, which is 3 jumps, and stop. It then says I need to remove -7 chips. So I need to remove -7 from my jumps here. So in order to remove -7, I need to start at -3, and I need to remove all of the chips and then some. So I'm actually removing, which means taking away negativity. So here I'm subtracting negative. Well, all the negative chips I have are only 3. So I'm going to remove all 3 of those chips. Those are gone. Removal means getting into the positives because those 3 chips are now gone. And then I have to subtract or remove 4 more. So I'm going to subtract 4 more. 1, 2, 3, and 4. And then I can stop right here. So now that I've removed all of those chips, I've removed these and then some more negatives. That's why it turns into the positive. So I have 4 positive left. And today I'm going to make sure I actually put the 4 there. Okay, so this problem is really weird, and I'm going to show you how it works with addition. Okay, so I'm going to show you how to actually solve this with the chips so that you can see it in action. Because I don't think a number line is as easy to see as the chips. So I had -3. And then it wants me to remove -7. Well, I can't remove 7 negative chips unless I create the possibility of having 7 negative chips. Right now I only have 3 negative chips, so I need to get this up to 7 negative chips. So I need to create the possibility by adding on 0 pairs. Nope. There we go. Now I have 1, 2, 3, 4, 5, 6, 7 chips that I can remove. And now that those 7 chips are gone, I'm left with 4 positive. So here it shows me taking away the 3, but then I need to keep going, and I've got 4. All right, so let's show this. I had 3, but then I needed to create the possibility to take away -7 by adding on 0 pairs until I have 7 chips that I can actually take away. Now that I have 7 chips that I can take away, I have 4 positives left over. Okay, so let's do this over here. -3 plus 7. We're adding the opposite in order for this to work, because removing a -7 really means that I'm adding 7. I've removed all of the negative, which means that I've moved away from the negativity. I'm filling it with positives. So 0, I'm starting At 0, I go to -3. And now I need to add on +7. So I'm going to add on +7, and that equals 4. Adding the opposite. Okay, it is your turn to do a try it. We are going to do 2 try-its today. We're going to do 1 minus 4. So you have a +1 and you need to subtract 4. So let's do try-its. So try-it number 1, 1 minus 4, and then try-it number 2 is 6 minus a -5. All right, go ahead and hit pause right now so you don't hear me solving these, and then we'll move forward. All right, come back when you're ready. All right, set up my number line. All right, I need to have 1 positive, so I'm going to go to 1. And then it says to remove 4 positives. Well, I don't have 4 positives to remove, so I'm going to take away what I can take away, which is 1 positive, and then I'm going to keep taking stuff away that's not even there. 1, 2, 3, and I end at -3. So I've kept going until I had nothing left to take away. So it equals -3. Okay, with the chips, it looks like I had 1 positive and they wanted me to remove 4 positives. I don't have 4 positives to take away, so I have to create the possibility by adding 0 pairs so that I can take away 4 positives. Well, now I can take away my 4 positives and I'm left with -3. Okay, the next one, I have 6 positives and they want me to take away -5. So I have 6 positives and they want me to take away -5. Well, I don't even have any -5s there. So one, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oops, I think I need to keep going. 11. All right, so let's take a look at this problem. So we had 6. We need to go to 6 first because our first number is positive. That's the direction we're going. So I need to go to 6. And then it wants me to remove -5. Well, I don't have any -5s to remove. And so really, if I had those 5 to remove, I would be removing the 0 pairs. So that means that I am now going to go all the way to 11. So what does this look like? Because that is a really bizarre one, right? Let's check this out with integer chips. Let's check this one out with integer chips. I don't know where I'm going to squeeze them in, so let's just shove them here. Okay, I had 6. Okay, so 1, 2, 3, 4, 5, 6, and I need to remove -5 chips. Well, I have to create the possibility by adding on 0 pairs. So there's those 5 0 pairs, and now I'm going to add on the negatives so that I can just remove them. So I've created the possibility by putting them on there, and now they're gone. That leaves me with 11 positive. All right, 6th graders, I know that this can be challenging to learn. And so if you have any questions at all, please make sure that you come back to the Google Meet. If you felt really confident with adding integers, add them. It's the same thing. So add the opposite. That's how we solve subtraction. So somewhere on your paper, I want you to answer your essential question. and then put your rating out of 3 where you're at. Again, come to the Google Meet if you need extra support. Otherwise, you can go ahead and head on over to your practice work. As always, Cougars, I appreciate all of your hard work, and make it a great day the Cougar way.